Up to this point, our strategy for finding the vertex and axis of symmetry from a standard form is to change it into a vertex form. Okay, so let's look for some, see if we can put together some things that we already know about the standard form and what we know about other things that might be able to lead us there in a different direction. Okay, so our standard form, let's start with it, ax squared plus bx plus c. And what we know from the standard form is that if we were looking for the x-intercepts, okay, so if we were looking for ax squared plus bx plus c equals 0, then the quadratic formula would tell us that those x-intercepts are at the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, when we've looked at the factored form and where the roots are, we said that because of the symmetry of a parabola, the axis of symmetry will be exactly halfway between the x-intercepts. So if we averaged these x-intercepts, so if we took them, the negative b plus the square root of b squared minus 4ac over 2a, and we added that on to the other one, which is negative b minus the square root of b squared minus 4ac all over 2a. And then we divided the whole thing by 2 or multiplied by 1/2. Then we should be landing exactly where the axis of symmetry is. Okay? This would be equal to that axis of symmetry. Now this is where hopefully there's some simplification that can happen here, and we can see right off the bat that these two fractions already have a common denominator, so we can write the numerators together over the common denominator one time. So we've got opposite of b plus or minus square root of b squared minus 4ac. Plus the opposite of b minus the square root of b squared minus 4ac all over 2a. And that's my axis of symmetry. But I have a positive square root of b squared minus 4ac and a negative square root of b squared minus 4ac. If I add those together, they just give me 0. So this now looks like a 1/2 times, that leaves me with a negative 2b over 2a is equal to x, which is a major simplification. This 2 divided by 2 makes a 1 there, so if I multiply the 1/2 in, I have the opposite of b over 2a. Okay? That this is where the axis of symmetry is, and if that's where the axis of symmetry is, then that is also the input that I would need to the function to figure out what the y-coordinate of the vertex is. Okay? And if I look at it, this is the minus b over 2a. I mean, that's this part of the quadratic formula out there as well. Okay, so we'll do one example real quick as to show what we're talking about. We'll make up a quadratic. We'll make it f of x equals 2x squared. I usually get myself in trouble when I make these things up, but oh well. So this will be our quadratic, and hopefully, well, let me make that a plus 3 instead, and then I think I'll be in a little bit less trouble. All right. So the process then tells us that we can skip all of those other steps along the way, and the axis of symmetry it says we'll have the equation x equals the opposite of b, which is negative 5 over 2a, so that's 2 times 2, and so that looks like a positive 5 over 4. So my axis of symmetry is x equals 5 over 4, which means my vertex will be located at 5 over 4 comma something. I'm going to use 5 over 4 as the input to the equation that I had. So I want to know what is f of 5 over 4, and that's going to be, I'll go ahead and put 5 over 4 in here, 2 times 5/4 squared minus 5 times 5/4 plus 3. So that's a 2 times 25 over 16 minus 25 over 4 plus 3. Looks like 16ths, or I can multiply here. This is 25 over 8 minus, this would be 50 over 8 if I found the common denominator there. And then plus, if I'm going to go over 8, this is 24 over 8. So that's a minus 25 over 8 plus 24 over 8. Looks like a negative 1/8 is the y-coordinate of my vertex. Okay. And of course, I haven't checked that and just kind of blasted through the math there. Okay, so I did pause there for a second and check just to make sure I hadn't made any dumb mistakes and published a bad video, but that looks like it works. So that is a considerably faster way of getting that axis of symmetry and the location of the vertex directly from the standard form. That should be just about all the tools we need for what we were trying to accomplish here. So I'll stop talking.